Welcome. This video covers more examples using the ggplot2 package to make plots. In this video, we're going to cover some of the basic plots that you would use for numeric data. Remember, when we're trying to describe numeric data's distribution, we want to describe basically three things: the shape of the distribution, the center, and the spread. We already looked at how to describe the center and spread with numbers, but we weren't able to describe the shape very well using just numbers. So that's where plots are going to come in handy quite a bit. But when we go to think about how to create these plots with ggplot2, the ideas that we did using the bar plots, they're going to follow through right here as well. What we're going to do is we're going to create our base object. So we're going to use the ggplot function itself to create a base object, and then we're just going to add the appropriate layers to that object. Within those layers, or perhaps within the base object, we will map variables from our data set to different aesthetics using the AES function. All right, let's talk about our first plot. We're not going to talk about an actual histogram here. You can make those using ggplot very easily. But instead, we're going to look at what's called a kernel smoother, or a smooth histogram. And the reason that I prefer these over histograms is just because histograms can be highly variable if you don't have a lot of data. And so these kernel smoothers do a little bit better job with that variability. And so how do we do this? Well, we're going to create a base plotting object. In this case, they're calling it C from the cheat sheet here. And then we're going to use the geom density layer. And by default, it's going to use a Gaussian kernel, which is fine. You don't really need to worry too much about that. This is just the weighting function that's given to each one of the points to create the smooth histogram. And here are the commonly changed aesthetics to a smooth histogram or a density plot. And the only one that we really need, though, is the x variable. So we need to tell it which variable from our data set should be plotted along the x variable, and then it's going to create that smooth histogram based off of the points that you have there. And so here is a basic density plot off of our Titanic data. We're creating our base plotting object. We're saving it as an object called G. We're using the Titanic data, and then we're going to map the age variable from our data set to the x. And then we're just going to add a geom density layer. And so you can see that this is now a nice smooth histogram. This gives us an idea about the shape of the distribution, right? I know that most of my data points look like they're falling somewhere right in this region, right? So somewhere between, say, 15 and 45 is where most of the people on the Titanic, those were their ages. And there were a few people that were quite old, and there were a decent amount that were pretty young as well. Now, we can do all of our other things that we did in the previous plot. There's a bunch of other aesthetics we can add in, and the great thing about ggplot is that it's going to automatically create legends and do the colorings for us and things like that. So if we go here, we're going to go to the geom density, and we're going to add some options to it. First one we want to focus on here is the fill option. So I'm going to be mapping a variable in my data set to the fill aesthetic, and so I need to put that within my AES. And so these density plots are now going to be filled based off of the survival variable. And here, what you can see based off of that is, well, it looks like the distributions beyond about age, 15 or 12 or so, looks like those distributions look basically exactly the same, but there were a lot more younger people that survived than died, which was kind of the big difference between those two distributions. Now, you might also see that these other two things, so these are other parameters that we can, other aesthetics that we can change as well, and settings to our smoother. And so the alpha aesthetic is the transparency, and we're just setting that to 0.5. Since we're not assigning the transparency to a variable from our data set, it does not need to go in the AES statement or the AES function. Instead, we can just set it to a standard value, and that makes it so that I can see through this blue density curve and see the underlying curve a little bit as well. And then the adjust, this is just an adjustment on the bandwidth of the kernel smoother. Now, those two plots were overlaying on top of each other. Well, remember that we talked about the position aesthetic, or the position option for our different plots. And so by default, for the smooth histogram, it's on dodge. But if we want to change that, we can certainly do that. So we're just going to add in this position argument and say position equals stack. And now instead of overlaying them on top of each other, it's going to stack the distributions on top of each other. So this gives us a different way to compare those two distributions. Let's talk about boxplots. Boxplots are a great way to describe the distribution of a numeric variable. It gives us the 5-number summary in a graph. So the 5-number summary is the minimum, the first quartile, the median, third quartile, and the max. And so it's just a visual of those points. How do we get those in ggplot? Well, we're going to use a geom boxplot layer. Some of the common aesthetics you might change, there's a whole bunch of them, but really the only ones we need are x and y. So which variable is going to be on our x, i.e. which is our categorical variable that we're going to be looking at boxplots of. And then which one is y, which you might think about a response variable, but really it just needs to be some numeric variable. Here's our box plot, and this is created using the geom boxplot layer. We've assigned the mySurvive variable to the x aesthetic, the age variable to the y aesthetic. So we see mySurvive down here, the categories, we see the age variable over here. And so what we're really seeing here is the minimum age for the survived folks, the first quartile, the median, Q3, and then this is the largest value up here for the survived people in terms of their age. We've used the fill aesthetic and we set that to gray, so that's filled the boxes here with gray. And again, this does not depend on a variable in our data set, so it does not need to go in an AES function. We might be interested in sort of the shape of the distribution in some way along with these box plots. They don't really give us a full idea of the shape, sort of modality, and things like that. So what we can do is just add a second layer. We can add a geom jitter layer on top of that box plot layer. We're just going to use a plus sign here and then add an additional layer. And what geom jitter does is this adds in points, but it moves them just slightly so that they don't sit right on top of each other. Because really all of the variables take on the value survived here. And so if we plotted them all, they would all just sit like right on top of each other, and we wouldn't necessarily be able to see if there were lots of points in one particular region. So geom jitter is going to add in points, but with slight perturbations, if you will. And I don't know if I can spell that word right, but slight perturbations. So they slightly move them around. And so we're just going to say alpha equal 0.3. Again, alpha is about the transparency, so we're going to make them pretty transparent points. And then width of 0.1 is just how wide do I want my jitter to be. If I did a larger width, you would see them spread out even more across those boxes. If I did smaller, it would look much more narrow. But this just gives us now an idea about where most of the points lie. And we can see that it looks reasonably similar, but again, there's sort of a few more points down here for the survived group than there is for the died group. It's really important though that we are careful which layers we put where, because you are actually like layering the graphs on top of one another. So for instance, if I put geom jitter first and then I added my box plot layer, the box plots go on top of the jittered points. And as they're going on top of the jittered points, it's covering them up. So that's not ideal. I mean, we could make these boxes transparent, and that would help, but generally speaking, it's just better to put the box plots first and then the points on top. You might also notice here that we are using these global aesthetics. All right, we are assigning the AES for X and Y up here in this ggplot statement, and so those are carrying through to any subsequent layers. You may also come across the idea of what's called a violin plot out there. Violin plots are very similar to box plots in terms of what they're trying to show you, but what they're actually doing is taking that smooth histogram and just mirroring it across this line right here. So if you just looked at this curve that you see right here, this looks very similar to the geom density curve that we made for the survived. And if we drew a line right down the middle and we looked at this curve right here, that looks like the one that we made there as well. So it's just mirroring that across that line. And how do we create that? Well, instead of using geom boxplot, we're going to use geom violin. All right, let's talk about scatter plots. Scatter plots are really, really useful for looking at the relationship between two numeric variables. And the way we get scatter plots is through geom point. The most common aesthetics are given here, and really the only ones we need are x and y, and both of these should be numeric variables. Here's an example of a basic scatter plot between the age and fair variables. I'm creating my base plotting object, I'm assigning x and y, and then I'm just going to add a point layer. And we see a scatter plot. This allows us to have some idea about the relationship between the age variable and the fair variable. And we can see that maybe there's a slight linear relationship. Maybe it's going up just a little bit in terms of the fair based off of the age. If we really wanted to investigate that, we could just add a smoothed in line, right? So we could add in a line over top of this. And so geom smooth is the way to add a trend line to a scatter plot. And in this case, there are different methods for that trend line. The default method is sort of a smooth line, but we can get just a basic simple linear regression fit by doing method equal LM. And so this is the simple linear regression fit between age and fair. Now, we might be looking at this plot and say, hey, I want to add some text to it. I want to put some information on there for the user when they're looking at it. Well, there's a very easy way to do that using geom text. But in order to start talking about adding in some text, it's really useful to know about the paste and paste zero functions. So paste and paste zero are both functions that are made to paste together or put together character strings. For instance, if I created a character string of hi, what is going on, and a question mark, I can separate all those by commas and put them within paste. And so if I use a separator of a single space here, it's going to put those strings together but with a space in between them. I can change the separator. So if I wanted to use a separator of, say, a period for some reason, I could do that. And it's going to put those character strings together, separating them by periods. Paste zero is just a shorthand for pasting them together with no separator. So you're just going to paste them right on top of each other. So no spaces or anything like that going on. How do I add this text in? Well, all right, I got my geom point layer just like we had before. I got my geom smooth, so those haven't changed. But now I'm going to go ahead and add one more layer. And that layer is going to be a geom text layer, which allows me to put text on a plot. And what text I want to put on there is given by this right here. Okay, this is the text that I'm going to be adding. You can see that I've calculated the correlation using that core function and the complete.obs option or argument here that we talked about previously. And so now that's saved in an object called correlation. That's going to have lots of decimal points, or lots of values after the decimal point. So instead, let's go ahead and round that thing to 2 decimal places. And then I'm going to paste the string of correlation equal with a space after it right next to the rounded value of that correlation. And so that's what produces correlation equal 0.18 right there. What are these other arguments? Well, these are just the arguments of where I want this text to be. So the X argument is 40, the Y argument is 400, and the size is 6. So 6 just means bigger than 1 is the default. 6 just means make it bigger. But you might notice that this X and this Y, well, I already had defined my X and Y in my global object up here, in my global AES up here. So if I had not defined X and Y, it's going to try to do it based off of what was defined up here. So I'm really using a local assignment of what X and Y should be down here to override that. And notice that none of these options down here in geom text are within an AES statement, because none of them rely on a variable within the data set. And, talking about points, or talking about adding text to a plot, you can actually plot your points without points, but with text instead. And we can just use that geom text layer to do that. In this case, I'm going to say geom text, my AES, I'm going to say the label for the text should be the survived variable. So I'm getting my X and Y from up here, but then the label that's being produced instead of a point, I want it to be coming from the survived variable, which was the non-factored version, so it was 0s and 1s. And then I'm going to color by my survived so that I get a nice looking legend over here with those 2 values. And so now I know that the red corresponds to survived, also that's a 1, and the blue is died, also that's a 0. Let's jump into R and play around with some of these plots. Here we are back in R. We're going to continue our cancer data example. So just to remind ourselves what those variables are. So this is a bunch of information about breast cancer patients. And we have a number of numeric variables within here, or at least variables that we can treat as numeric. And so we might look at, perhaps this is, I believe this is recovery time and age. So we might be interested in those 2 numeric variables and their relationship. Let's go ahead and create some plots for numeric variables. There we go. I'll toss in a code chunk with my hotkeys, and we'll go ahead and create a base plotting object. And let's just start with a smooth density, just like we did before. We'll go with ggplot. We'll specify the cancer data set, of course. And then we'll specify some of the AES arguments here to be global. So we'll say that the X variable, let's go ahead and make that recovery time. Now let's make that age in this case. And then we'll do G plus geom underscore density. we'll just use the defaults for that. And so here's a histogram, or sorry, a smooth histogram based off of this age variable. We can see that most of the women here were, say, between 40 and maybe 70. Let's do another one for the recovery time. So I'll copy this and just replace age with rec time. Looking off that, this must be in days, I would guess. And looking like a lot of the recovery times are shorter, but it's a skewed right distribution. Gives us a pretty good idea about where we see these recovery time values. All right, let's go ahead and look at some of the relationship between these two variables. So we'll go ahead and create some scatter plots. We'll use that same cancer data set. We'll specify some global aesthetics. X will be age, Y will be recovery time, and then we'll do G plus geome point. We run that code, and didn't look like much of a relationship to me, but it's always useful to add a trend line here. Let's go ahead and do that. Drop that down a line. We'll add another layer, geome smooth. This time I'm not going to use the simpler linear regression fit. I'll just use the default, which is a locally weighted sums of squares fit. So it's like just a smooth line, if you will. And we can see that really there's not much of a relationship. There's not a linear or a positive or a negative relationship for the most part. But this gives us a nice way to easily create really nice looking plots. Well, hopefully you're starting to get a little bit of a handle on how this ggplot2 package works. Seeing more and more examples hopefully will open up things for you. And again, that cheat sheet is really, really useful. If we jump over and look at that, if we start thinking about plotting continuous variables, or numeric variables as we're calling them, here are the common plots that you might use, and they give you, again, the information about what layer you're going to add and then the common aesthetics you would change. Sorry, if we go up here, we can see for two variables the kinds of plots that you would make. So we focused on geome point and geome text, but there are a couple other ones that are very common to use. And so the process, though, is very similar across these, right? Base plotting object, add in your layers, map your variables to these aesthetics using the AES function. Next up, we're going to look at some really interesting extensions and the idea of what's called faceting, which will really allow us to create a lot of really cool plots.